Now let's talk about scanning techniques. It is important to understand how they work. In this video we will review just basic introduction to scanning methods. The goals of scanning can be different, for example port and host discovery, firewall and operating system detection, and there are different ways how to perform it. We just briefly review some techniques depicted on this slide. ARP Sweep is used to discover online hosts in local area network. Let's imagine that we need to find all alive hosts in the following range. Here is the principle of how this technique works. ARP protocol is used to map IP and MAC addresses. Pentester just sends broadcast requests like "who has this IP" to any network devices. When device receives incoming ARP request, it analyzes its own IP address with IP address in ARP request. If they match, the device replies to Pentester. In the network we have 3 hosts. 2 of them are online, and 1 of them is offline or just switched off. Pentester's laptop broadcasts the first probe. But only 1 computer replies. Pentester receives reply and marks this computer alive. Now the same procedure repeats for the second and third IP. The third computer does not reply, and this host is marked not alive. This method is very good, but it doesn't work through internet. Let's do the same task, but this time with the ICMP protocol. ICMP is used to inform about network problems. The principle of operation is very simple. Pentester just sends unicast echo requests to the remote host. If Pentester's laptop receives replies from given host, it's marked alive, otherwise not alive. Let's have a look at this closer. We have the same hosts. Pentester sends packets to each host and waits for the replies. On each iteration, the procedure is the same, but with different destination addresses. This method works well in LAN and Internet, but very often most firewalls block incoming ICMP echo requests for security reasons. Okay, we just found online hosts. Now it is time to discover what services are running on them. In this example, our task is to find whether port 80 and 445 are opened or closed. The most popular method is TCP Connect. We just try to establish connection with remote host on the certain port. If connection is successful, port is opened. This method is based on 3-way TCP handshake. Let's see how it works. Pentester initiates connection by setting SYN flag in the first TCP packet and sends this packet to the remote host. If port is opened, remote host replies and sets SYN and acknowledge flags in outgoing TCP packet. To complete connection, Pentester sends the last packet and sets acknowledge flag. From now, Pentester knows that port is opened. Finally, Pentester sends another packet with a set reset and acknowledge flags. These flags are used to drop established connection. We don't want to have dozens and hundreds connections with the remote host. It will be very suspicious. Now let's see what happens when port is closed. Attacker sends SYN packet, but remote host replies with a reset acknowledge packet. Given technique is very slow. It can be easily detected, but at the same time it's very reliable in detecting available ports. Let's consider how to detect UDP ports. We have the same task as before. The principle of operation is the same, like ICMP Sweep. We just send empty UDP packets to remote host. If we receive reply, the port is considered open. If there is no reply or we just receive ICMP destination port unreachable, the port can be considered closed or filtered by firewall. Let's see how it looks. Attacker needs to know whether port 53 is opened or closed. So he sends a UDP packet. Remote host replies by sending UDP packet and from now attacker knows the port is opened. But what happens if the port is closed? There are two situations. Attacker sends UDP packet, but remote host replies with ICMP port unreachable message. This message can be generated by host or firewall, so attacker may assume the port is closed or filtered by firewall. In the second case, remote host does not reply. This means the same as in the first case, port is closed or blocked by firewall. In real life, it's very hard to detect available UDP ports, because UDP is connectionless and unreliable protocol. We already talked about firewalls. Today, firewall is normal in every network. But there are several types of firewall. Stateful firewall is an intelligent device which remembers all outgoing connections. Stateless firewall is a simple network filter. It does not remember any outgoing connection. TCP Acknowledge Scan technique is able to detect above-mentioned types of firewall. The principle of operation is simple. Attacker sends TCP packet with a set acknowledge flag. As you know, the packet with a single acknowledge flag is used to complete three-way handshake. Many stateless firewalls are configured to block incoming packets with a SYN flag, but all other packets can be passed. When the host receives TCP acknowledge packet, it will drop it and sends TCP reset packet. When stateful firewall receives TCP acknowledge packets, it will just drop or block it. In this case, attacker can receive ICMP destination unreachable message, or no reply can be received. Let's have a look at how it works. Pentester sends the packet. Firewall is stateless and passes the packet. Remote host will always reply with TCP reset packet. When the firewall is stateful, it replies with ICMP destination unreachable. Or it doesn't send anything.